Thanks, everybody. So to start off, let me tell you a little about Rescale. We've been around since 2011. The company started out focused on aerospace and moved on to automotive. At this point, we are the leaders in running high-performance computing on the cloud for both automotive and aerospace. So in about a year ago, we started looking into moving into semiconductors. So we have a proven engineering solution for this space. Like I said, we're the leaders in automotive and aerospace HPC cloud right now. So I'm going to talk a little bit more high level about where we are in the cloud today for semiconductors. So today, I think most of us know semiconductor development will go to the cloud. What that looks like is still being talked about, right? We know Cadence and Synopsys both already have their own proprietary cloud practices, right? TSMC has a cloud solution as well. So we know that acceptance is coming. So far, though, what we see is that the IT organization is the ones that are more bought into it at the customers, right? They're the first ones to feel the pain. They're also the folks who have had more experience. You've got folks from outside the industry who've come in with cloud experience, and cloud's getting more accepted there. You've got the CAD managers. These are the folks who own the EDA flows. They're the ones who have the challenge of making this flow work from what works on the on-prem to on the cloud. Design teams, however, is where we see more skepticism. So these are the folks who they have concerns about data leakage. They see it as an unproven solution, and not all of them have embraced the productivity gains and the improvements that can come from the cloud. So let's go with why should EDA go to the cloud? So we all know what Moore's Law is, but basically what it talks about is being to deliver more functionality for about the same amount of price. But if you look at that functionality, with each design shrink, you have more resources that are required. So what we're also seeing is that compute infrastructure demands also grow exponentially as we move forward, right? So even large organizations are starting to see a problem with being able to service this, where most companies are on a 2 to 5 year depreciation cycle. That means you're refreshing your systems every 2 to 5 years. That means that for the most part, the average system in your environment is probably 2 to 3 years old, right? So given that, on the cloud, you can find newer systems and faster systems because they're available right away. You just have to choose what you want, right? In addition to that, you've got a lot of times, depending on your company size, you may have a shortage of large memory systems as well, so jobs have to wait. On the cloud, you can find large memory systems as well. Those jobs don't have to wait for systems to become available. So what would make things easier to use is a turnkey solution, something like what Rescale provides, right? We get you up and running in days and weeks rather than having to build everything, which usually takes months to almost a year. Also, running on the cloud, because you can run on faster systems, it gives you better and more efficient usage of your existing licenses. So one example of where this can happen is basically with Tapeout. Oftentimes what you see with Tapeout is, as you approach Tapeout, you go into your IT and you ask them to bring in extra systems. For example, if IT can bring on like 200 more systems, you'll go to your simulation vendor and your verification vendor and ask for maybe 200 more licenses for 2 weeks, right? What that covers you is basically, typically in verification, you've got a bucket of tests that you have to run, that you must run. There's a bucket of tests that you should run. There's some that you really want to run. And there's the stuff that lets you sleep better at night because it should work, but you're not 100% sure. Given the resources available, typically what we see is customers wind up, what you actually test is the stuff that you have to do and the stuff that you should do. And that's covered by that 200 licenses in 2 weeks. Now, if you can run on the cloud, you're no longer restricted to 200 systems, right? You can get as many systems as you want. You can get the fastest systems you want. So you can go to the same vendor and ask them for, instead of 200 licenses for 2 weeks, 400 licenses for 1 week. The area of the curve is still the same, but what you get is the ability to run more jobs quicker, because typically none of your jobs are running more than a day or two. So instead of having them run in series, you push them forward, you shift the entire simulation left, where if you find a critical bug in that second week, you may not have time to respond. This way, you'll find the bugs sooner, you have time to respond and verify it properly. Now, if you finish everything and you don't find a bug, what that frees you up to do is make an engineering decision of whether you want to go ahead and buy more licenses to do the stuff that you would like to do, and stuff that basically could possibly reduce your risk of respin, right? That's one value. Another area is large memory systems, like I mentioned. Oftentimes, if you don't have enough large memory systems available, and you've got designs that want to do static timing analysis, formal verification, place and route, they're stacked up and they have to wait for systems to become available. If you could go to the cloud and find large memory systems, you already have the licenses. You can run all of these four at the same time and run them in parallel, right? That way, you can get your workloads done faster. So that comes to what makes sense to run in the cloud, right? We don't think all jobs should go to the cloud. There's definitely some that are more advantageous than others. So if you look at the design flow, there's a lot of different jobs on there. And what we think is that the highly parallelizable jobs are the ones that make sense. So library characterization, where you're running, this typically happens in a few months. You're running the jobs, sorry about that. You're running the jobs for about 2 or 3 months, right? It's a one-time event. It doesn't happen all that often. If you're able to run it on the cloud, you don't impact all the other workload that's going on. Another area is verification, right? Either logic or circuit simulation. Those are bursty workloads where it makes sense to basically take some of those workloads and bring it to the cloud, especially in areas where, like I said, tapeout or other events like that. DRC is another one, and extraction is also another area where you oftentimes can parallelize those workloads across many systems for better efficiency. And for those who do it, OPC and mass synthesis, also very parallelizable workloads. Another area, like I said, is the large memory jobs, layout, static timing analysis, formal verification, and nowadays extraction is becoming large as well. Okay. So the next question is, how should we run in the cloud? There's two philosophies, lift and shift and hybrid, right? Lift and shift says move everything to the cloud, right? That's challenging for EDA because what EDA oftentimes we have revision control systems that have been built off over the years. We've got scripts that are probably older than most of us today. They're written by people who are long left the company. No one really understands what the guts of that are. They work, but you don't really know why they work. Lifting that into the cloud and retooling that in the cloud is pretty risky, right? Also, you need to move all of that plus your job schedule up to the cloud. There's a lot of moving parts there, right? Also, if you moved all your data to the cloud, that means that as you do all your iterations and your every single version of that design goes up on the cloud, that actually is a lot of data to store. In fact, some designs can get up to the petabyte range. And not all workloads are optimal in the cloud. You don't want to necessarily do any of your schematic stuff on the cloud. Synthesis isn't that intensive, so moving some of those into the cloud may not make sense. In a hybrid approach, we think that there's going to be a baseline amount of workload that most companies will keep on-prem, right? And it's only selective workloads that go up into the cloud. For example, when oftentimes you do design, you have merge points along your design where several teams are going to have to come together and merge your designs together. This is an area where you synchronize your data across those workloads, right? When you do this, that's also an ideal point where you can synchronize that data at that point up into the cloud, run those workloads in the cloud, freeing up your data center to allow the engineers to continue doing their work and lessen the impact of merges in your infrastructure, right? As those merge points happen, that's also where, the ultimate merge point is a tapeout, right? So those strategic milestones are a good place to decide to basically move workloads up into the cloud. Also, that way you keep your workloads with dynamically changing data on-prem. You run workloads that make sense in the cloud, and you only bring back the relevant data. Because a lot of times when you bring the data up to the cloud, you run your synthesis on the fastest systems, but then when you're done, your analysis doesn't have to be on those fast systems. You can choose cheaper, slower Linux desktops to do awk instead or whatever you want to do those analysis, right? And then when you bring it up there, you only want to bring back data that is important, which means that if it's successful, if the jobs pass, you just bring back you compress your log, bring it back, and dump the data. You don't care about that. It's only the failed jobs that you want to bring back. Okay. Also, what you need to do to run the cloud, what pieces do you need to do to be able to run stuff in the cloud? First, you need security, first and foremost. You need to basically build a security layer into whatever platform you're going to run into the cloud. You also need job orchestration, something that starts and stops the clusters and manages when the jobs move. You need shared file system. EDA still relies on a file-based interface for a lot of it. Libraries, all that are file-based, right? You need system management. You have to track what's running. You have to monitor your environment. You need the ability to monitor jobs. You need the ability to monitor how much memory systems are using, how much compute they're using. If a job fails, why it fails. That analysis needs to happen. And you also want budget controls. One of the things we hear from customers is that if I run in the cloud, how do I stop an engineer from running 10,000 jobs in an instant, right, and blow the budget? So you want to be able to build a way to manage that flow. Oftentimes when you do that, you're playing general contractor with either your own teams or a bunch of vendors, where you have to put it all together. You have to build it, you have to test it, and you have to maintain it. So that's a lot of cycles to go through, and also you have to update it as time goes on. So the other option to do is to find a turnkey solution, one that does everything, all that already for you, something like Rescale. Right? The first question we always get is security, right? So in this market, security is key. So Rescale, given the fact that we have our roots in aerospace, we've done a lot of work on the security front. We've got certifications here, a lot of security certifications. And while these certifications don't mean a lot in EDA, but one thing that we do understand is ITAR, right? ITAR is a government military certification that we can run. If we connect, as long as we connect to the government cloud, which handles the physical security, our platform's security is strong enough to handle ITAR. We are also on our way of getting our FedRAMP certification, which is a federal security certification for working with the US government. Our platform provides things like user management, role management. We can manage groups, projects. You can assign budgets, resources accordingly, right, along those lines. We also have access to hardware across multiple clouds. I talked about security already. Cost management, I mentioned that you can, with our platform, you can actually assign budgets. You can assign allowances to projects and users. You can assign users a certain amount of money they can run every week. You can assign them a certain amount of hours they can run every week, however you want to manage that. You can limit how long jobs can run. And we also work with you guys to do the connectivity between your on-prem resources and the cloud. So the question of DIY versus already built, right? So with a DIY solution, you have something that's more customized, something you have control over, something that looks the way you want it to look and functions exactly the way you want to function, right? But with that comes the development challenges, the testing, the maintenance, and the time to build. It takes a certain amount of time to build this, right? Ready-built solutions give you instant access. You can basically get up and running in almost no time with minimal engineering efforts. What you do give up is that the interfaces are predefined. You have to adapt to existing interface. So a lot of times you think about this, it's do I want to customize this, and do I want it working just the way I want? If you think 10 years ago, that's like building a Linux laptop rather than just getting something that runs Windows or Mac, right? Either you get something that just works, but it's not quite how you wanted, how you would build it, or something that you can customize, but takes a lot of work and a lot of investment. The other question we get a lot is, how do you handle storage, right? Storage in the cloud is challenging for EDA because what you get is that typically you have object storage, you have file storage. You don't have a lot of file storage, and then you have block storage, right? So what you want to do is leverage S3 for cost. Move the data up to S3, and then move it into the file storage when you need to use it, right? Also, like I mentioned, you want to target major milestones, so you can move just the data you need up there. One thing that you can do on the cloud is the fast instances you choose often comes with NVMe, which is something that a lot of folks don't pay for on-prem, but in the cloud it's already there. Leverage NVMe for scratch. That gives you the fastest scratch space. You also alleviate a lot of your the issues you have for on-prem. You're writing scratch to the NAS, and your filer starts getting bogged down with all these writes. By using the NVMe for scratch, you alleviate that problem on the cloud, and then you write the data out to S3. The good thing about S3, while it's not high performance, so you don't want it for reads, but when you write it out for just your finished data at the end, you can actually associate metadata to that allows you to go ahead and have better information on what those runs are, right? So you want to also run, like I said, run your analysis on the cloud, where you're not pulling data down that you don't have to, because oftentimes egress costs a lot more than moving data up. So if you can actually do those analysis on the cloud and basically dump the data that you don't need, that saves a lot of money, compress the data and bring it back. Okay. Another question we get all the time is on-demand licensing. And I don't speak for any EDA vendors, but what I can say is I was a customer, I worked at a vendor, and I have to say, one thing that we as an industry should understand is that on-demand licensing is not about reducing EDA license spend, right? That's not the way to look at it. What on-demand gives us is the ability to better match our compute resources to engineering needs, right? What it really provides is the ability to be more flexible and respond to the variations in engineering requirements, right? You can scale up for unforecasted demand, and you can parallelize workflows where otherwise you'd be license limited, right? What this gives you is productivity gains that is outside of tool costs, right? And we as an industry pay for that kind of stuff, right? So basically what you do is you get the tool when you need it, when you need to run it right away, right? It allows you to scale better. So that gives you the ability to trade off spend versus schedule and risk, right? So overall, I think that's how the industry should be looking at how on-demand license comes into play. Where can we go in the cloud? So this is getting more in, I guess, speculative, right? So disclaimer, this is not talking about any features anyone has promised. This is basically, once we get to the cloud, once we're comfortable with the cloud, what can we do once we get there? So architecture-specific tools. So today we're in a chicken and egg situation. One thing I get asked about is, why don't we see GPUs in EDA, right? Most other industries, HPC industries, are running GPUs. One of the things that happened in that arena here was the tool vendors want to wait for customers to have those capabilities in-house before they adapt the algorithms for that. Customers want the tool to be available before they'll invest in it. And by then, the time has passed. So you're just watching each other get ready, and no one ever does anything. Now, what you can do is, in the cloud, we have things like GPUs, FPGAs. These things already exist, right? So customers have access to them right away, which means tool vendors can go ahead and build for that to run in the cloud. Customers can use it right away once the tool is produced. So imagine if there's a particular algorithm function that you can build into an FPGA load that into the cloud, run the tool, and it makes use of it. It can completely change the way we run things, right? As tools also bring AI into the mix, right? There are processors on the cloud that can do AI today. They're optimized for it, right? We don't make use of it, but we can, right? So these are things that once we get comfortable in the cloud, it can open up new methodologies for us. Because oftentimes, our methodologies are built on restrictions that we had to live with. Another thing is storage. What can we do with storage once we're on the cloud? So if you control the platform, what you can do is also control access, right? So imagine if you can control access to storage volumes, where the tools, if you run the tools themselves can see certain protected volumes, but the user who launches them cannot. Because oftentimes, the user only needs to know what those libraries do. They don't need to see how they work on the inside, right? So if you can provide this kind of protection, then you can basically allow stuff to be run by less trusted customers, right? That means IP companies can provide IP to customers that may not necessarily have the best security controls, because while the tools can see the data, the users themselves cannot, right? Storage-aware tools, like I mentioned, if you're able to develop tools that are storage-aware, they can read from file, run on NVMe, and maybe write out an object with associated metadata that tells you when the job was run, what the job is, and all the information that you can need to do better analysis on your design moving forward, right? That also brings in the possibility of doing things like federating storage across different companies, where you can trade data and transfer data from one company to the other. Right now, when you go ahead and when you tape out, you have to send a large amount of data across to another company, right? But what if they can just attach to that data and read it directly as they need it, right? You can get rid of some of the issues that you see today in terms of data transmission and such, okay? And that's it. Any questions? Yes. Yes.
But in the industry, my impression is correct. So far, many companies still using NAS.
Yes.
And I do know that the NetApp, EMC, they all have shared file system, but they are relatively new. And NetApp only make the NFS shared file system available in cloud recent years, like starting from last year, with the cluster, the C in C mode, so to speak. So how can you address that today?
So there are a bunch of shared file systems available in the cloud today. For Rescale, we actually developed our own shared file system that customers can use. And basically, what you want to put on the shared file system is your libraries, your design data, stuff that multiple tools need to read, right? So our solution was to build our own, right? But there are other solutions out there that you can integrate in, okay?
Let's say, for instance, just pick a very simple one. Lustre is available in the AWS already.
Yes,
So could you just high-level-wise describe how you integrate it?
So it depends on how you build it. Like I said, for us, we built our own. On our platform, we have a shared file system. We had a shared file system called high-performance storage, right? So in there, we can define volumes where you can store things like your design libraries, your design files, files that you're uploading that are changing the differences, the deltas, right? So you can pull from all of those as your read data, right? And then process it on each of your compute nodes, and then write that data out to common S3 storage.
Okay. Now a follow-on question. My observation of parallel file systems and file systems in general is that it takes roughly about 10 years for a file system to mature. So if you have written your own, I know you guys have been in business for quite a while. Consider reliability. Are you comfortable claiming that it's really, really reliable?
Well, you can try it and find out.
Okay.
Right? Run it on the platform and find out. Okay? I mean, there's proving reliability is you're trying to prove a negative, right?
Yeah.
So the only way you can prove that is by experience.
Tests.
Yeah. Okay. Yes. Okay.
Thanks.
Any other questions? Okay.
Your FedRAMP certification, is that pretty near term or?
So it's pending. We have a sponsor already, right? So the timeline, we're expecting it very soon, right? Since we have a sponsor that's kind of getting close to being real, right? So there's a process. It's a government process. That is what it is, right? So. All right. There are no more questions? Oh.
Sorry.
Can you go into your BOYL policy?
Okay.
Bring your own license?
So basically for Rescale, customers have the relationship with the EDA vendors, right? We do not resell licenses, right? So customers will come to us with a license from the vendor, at which point we can handle one of two ways. If the customer wants to run their own license server, we can create a tunnel in through VPN and grab licenses off the on-prem license server to service the cloud. The other option is to get cloud resident licenses. If you're running enough stuff on the cloud, you can get licenses from the EDA vendor, and we can host those licenses for you. At which point we can host licenses on the cloud for the cloud work, and we can also create that same connectivity into your network so you can run on-prem workloads using the licenses from the cloud as well, right? So we can actually host licenses for you also. Different customers have different preferences. We can basically be pretty flexible. Okay, any other questions? All right. Okay. Thank you.
Thanks a lot, Rich.